now we can test it. I was already testing it a little bit ago, so let's see what ports we have open. So first of all, what did I have uncommented here for the port number? I'm using 8738. So let's see if 8738 is in my list here. So 8738 is not in my list, and it's only the first three here, TCP, the bottom four, what is this, 5? 1, 2, 3, 4, 5 are TCP6, which is not what we need. IPv6, we're paying attention right now to IPv4. So it's only these top three. There is no 8000 number in there. So good. So it's not open right now. So if I take and run my program, which let me quit out. I already had the debugger going here. So clear that out. First, I'll show you what happens when I run my program. Actually, I'll save time. I'll just show you what happens when I run it in the debugger. If I just straight up run it, it doesn't look as interesting because as soon as it makes a connection, it immediately breaks the connection because I don't have anything in there to prevent it from getting to the exit service call right away. So it's not as interesting. It's a little more interesting if I run it in the debugger. So to start the debugger, we got to set our branch, start, run, step, and I can actually just keep stepping, and when I get to the part where it's waiting for a connection, it will just wait, which is right there. So it dropped down, kind of funny. So now that should mean, and you'll notice in the things we already called listen, we already called accept. Above that we would have called up bind and socket as well. So now I should see that 8000 number in my list of ports, which I do right here. And it is on the IP address that I had uncommented, the one that I had it set to 127.0.0.1, and it's set to listen. So now if I just pull up telnet, which again I already did that just a second ago, but let's clear it. So telnet localhost into my port number with my port number, or I could type the IP address as well. The IP address represents localhost. There's kind of a weird thing. I don't actually know why that is. It says failed, connection refused, but then it says it connected. Maybe I do have to type the IP address. I'm not exactly sure what's up with that. So I've been studying some networking for fun, and I started with, just learning about the different protocols and stuff, the OSI model, and then when I moved to trying to pay attention to the software side of things, I looked at doing, setting up a server and a client, but I kind of wanted to know how it works at a deeper level. So here's some Python code. I got this online. I did not write this Python code, and it's a little more advanced actually than what I want to illustrate at the moment. But I just basically want to show that the backbone of this this client program here, it's calling socket, and then bind, and then where's it at? Bind, listen, and then accept. And then it's passing them some parameters. So inside a socket, it's passing AFINet and SockStream. Inside of bind, it's passing a server IP address, which they have up here as 127.0.0.1 localhost. And then for port number, they're using 8000. And then for listen, they're just passing 0, and accept, they're not passing anything. The rest of what they're doing here is not really of interest for me in this video. And again, here is some C code. So if we step it down a little bit, I also didn't write this C code. That's not the point of my video here. This is just some C code from somewhere online. And unfortunately, I don't remember where I found it now. So at the top, they have all these header files. And then the main part that I want to talk about, they're going to call socket, bind, listen, and accept should be in here somewhere. Right there. Accept. And when they do socket, they're passing it AFINet and sockstream and 0. So these two were in the Python one, AFINet, sockstream. They're also passing it a 0. And then for bind, they're passing it a socket file descriptor, which you'll notice that is the output of when they called socket. And then the second parameter, they're passing it, it's not super clear from here, but this is a struct that represents the address information. And then the size of the struct for the address information. For listen, they're passing it the socket file descriptor and a number 5. And then for listen, accept. For accept, they're passing the socket file descriptor, this struct again. I'm just assuming this is, yeah, I did test this code out and it did work. They're also passing the size. And then, so now when we look at it in assembly here, let's go ahead and make this big again actually. We see that there's a lot of similarities. So it looks different at face value, obviously, because it's assembly. And then, but the code is still structured basically the same. You have and the reason is because these were all Linux system calls. So the first block here is to call the Linux system call for socket. The next one is to call the Linux system call for bind, then listen, and then accept, just like in the other ones. And then all you're actually doing here is setting up parameters. And actually the parameters follow the same order that they do in C, to the point that when you look at the documentation, you're actually looking at, well, everywhere I found the documentation, even when it's talking about in assembly, it's referencing how you lay it out in C, and the parameters are in the same order. That's how you keep them straight. So the first parameter for socket actually in both Python and C, although it wouldn't necessarily have to be true in Python, but is AFINet. Now the issue is when you program for assembly, AFINet is a number value, and it's actually kind of hard to find out what the number value is based on your architecture. It's not necessarily always a 2 because it's assembly. It's a 2 because I'm doing this on Arm64 on my Raspberry Pi. So the same for the rest of these parameters that are numbers. So the second parameter was set to sockstream in both the other examples, and here sockstream is represented by the number 1. So this is still sockstream, but it's represented by a number. The third parameter is 0, which I believe Python didn't have a third number, and the C code did have the same third parameter. Then what we do is we move the system call number to x8, and we call the service call, I believe is what SVC stands for. We call Linux and we say, hey, we want you to execute 198. Here's our other parameters. When you're done, it returns the socket file descriptor into x0. And so the socket file descriptor, what you're doing when you call socket is you're allocating a place in memory for address information to go. And the socket file descriptor is like the it's every open file has a file descriptor, and so this is the file descriptor for that. And every single time I ran it with my particular code in my little setup, it gave me a number 3. But if I had opened a bunch of other stuff, it would have given me a different number. It just happens that I don't do very much on this machine. So yeah, and then that gets returned in x0, but we can't leave it in x0 because we're going to use x0 as the first parameter every time we do a system call. So we had to move it somewhere else. So I just stored it in 4. And at the first parameter for every one of these other ones, bind, listen, and accept, is always me taking the file descriptor out from x4 and moving it to x0. So there I do it for bind, for listen, and for accept. The second parameter here in bind is the one that really gave me a lot of troubles. I spent a whole week trying to get this to work right, and I don't know. It's the kind of thing, once you know how to do it, it looks simple, but um, different tutorials and things that I looked at had the so I'm pointing to a struct right here that I have set up down below. Um, it looks like a mess because I have some extra stuff commented out, but I'll go over that in a minute, what it's actually doing. But I have it set up down below. There was some discrepancies on how big, how wide the data should be, maybe the order of things. There's some issues about whether it's big Indian or little Indian, and there's some issues about how much padding to include at the end. So it took me quite a while to get this working, and I actually tried disassembling the C code. And the C code is sort of doing the same when I hit main here, although this is line 155. So if I scroll up, I'm not even gonna go all the way. Well, I guess I did. So there's a lot of other stuff going on in the disassembly here. But when you get to main, you can kind of see that we call socket, bind, listen, and accept. And you can kind of tell from the easier parts, like socket, they put them upside down, but it was X0, they're using W0, but it was 2, 1, 0, so they're the same, but they have a lot of extra stuff going on. And the part specifically that I was having troubles with bind, they're doing all kinds of crazy stuff, and they're pushing to the stack, and just it was not easy to follow. What's funny to me is I actually got it working by asking ChatGPT how to do it, and it didn't give me the right answer the first time, but the second time it gave me what I needed for how this is supposed to be laid out. So yeah. So, and I tried putting in the hex values, just hard coding them in here instead of even making a struct down below, but I saw people who did that in tutorials and it worked. For some reason it did not work for me. I'm not sure what I was doing wrong, but I couldn't get it to work that way. I got it to work this way. So it's pointing to this address. The address, it looks like a mess, but it's actually just a half word that represents the protocol like style. So I have 2 entered for AFINet. Then it is a half word for the port number, and the thing is you have to flip them. So if you were to take, like, and these ones I have commented out, 8080 in hex is actually 1F90, but you have to flip the bytes. So the 90 is the last byte, it has to become the first one. 1F was the first one, it has to become the last one. And the same is true then the next entry is the IP address, and it's a word, and it's the same. So the IP address 127.0.0.1 is 7F000001, and when you flip it, you have to take the last byte 01 and put that first, and the next 2 bytes are just 00 and 00, so you do 00 and 00, and then you take the 7F and put that next. And then you have to fill in a quad of zeros for padding to fill it out to be the right size. So that's what goes into bind. That was the challenging part. Then the next one is just the length of the address information, which is 16 bytes, and it's going to be 16 bytes because it's IPv4. And then we do our system call number, and we call Linux, and pretty much the same. Listen, again, we're going to put the file descriptor in. Then we're going to put in a number that represents the max size of the queue of pending connections. You can kind of put whatever you want there. From this little type project like this, it really doesn't make much difference. And then accept is just going to take the file descriptor, and the next 2 parameters need to be 0. And that's pretty much it. The code's actually pretty simple. Now we can test it. I was already testing it a little bit ago, so let's see what ports we have open. So first of all, what did I have uncommented here for the port number? I'm using 8738. So let's see if 8738 is in my list here. So 8738 is not in my list, and it's only the first three here, TCP, the bottom four, what is this, five? 1, 2, 3, 4, 5 are TCP6, which is not what we need. IPv6, we're paying attention right now to IPv4. So it's only these top three. There is no 8000 number in there. So good. So it's not open right now. So if I take and run my program, which let me quit out. I already had the debugger going here. So clear that out. First, I'll show you what happens when I run my program. Actually, I'll save time. I'll just show you what happens when I run it in the debugger. If I just straight up run it, it doesn't look as interesting because as soon as it makes the connection, it immediately breaks the connection because I don't have anything in there to prevent it from getting to the exit service call right away. So it's not as interesting. It's a little more interesting if I run it in the debugger. So to start the debugger, we got to set our branch, start, run, step, and I can actually just keep stepping, and when I get to the part where it's waiting for a connection, it will just wait, which is right there. So it dropped down, kind of funny. So now that should mean, and you'll notice in the things we already called listen, we already called accept. Above that we would have called up bind and socket as well. So now I should see that 8000 number in my list of ports, which I do right here. And it is on the IP address that I had uncommented, the one that I had it set to 127.0.0.1, and it's set to listen. So now if I just pull up telnet, which again I already did that just a second ago, but let's clear it. So telnet localhost into my port number with my port number, or I could type the IP address as well. The IP address represents localhost. There's kind of a weird thing. I don't actually know why that is. It says failed, connection refused, but then it says it connected. Maybe I do have to type the IP address. I'm not exactly sure what's up with that. I mean, it worked. I don't know why it shows up refused the first time, and then it tries the IP address instead of localhost, and then it makes it in. So now we're connected. On this side here, I don't remember if it changes anything, to be honest. We have, yes, we do. We see that it changed. So in the above status here, I had we're listening and there is no established connection. Down below, we're still set to listen, or no, actually not, sorry. We're set to established. We have my local host, and then we have the port number on the other side of the connection. And then down here, we have a new one for the port number that is the other side of the connection that is connected to my, I guess, my process right here. And inside of the program now, you'll see it kind of moved on to the next line. So if I continue to step through this, once I put in a bunch of random junk into the code just to kind of stall this process out so it wouldn't immediately get to the exit code. And once I get to the actual exit code, you'll see it closes out the connection. There, so the program stopped running because we went past the exit system call. Now I go over here, you'll see that the connection was closed by the foreign host and we're kicked out there. And then over here, if I run netstat again with the parameters that I've set, you'll see that the local host on port 8738 connection to localhost on this other port that it set automatically in the 59,000 range now is no longer in listen, it's in time wait. And I don't know how long I wait, but eventually if I do it again, it'll disappear. I don't know how long it takes. It might be a few minutes, but anyway, that's pretty much it. There's a little bit about Arm64 doing system calls for networking.